Hi friends, my name is Muhammad Imran and today we are going to discuss a very common topic, that is analytic function of our new launched program, or you can say course on Moodle's cloud, that is complex variable. So let us start the topic analytic function. From the very basic thing is definition. So definition of analytic function is a single valued function which has a unique derivative at each and every point in the given region is called analytic function. It's called analytic function. So this was the definition of analytic function. Now we are going to understand how can we find out the analytic function when we have a real part and we do not have the imaginary. So let us start with a numerical problem. So our numerical problem is find the analytic function when the real part is x square minus y square. So the solution of this numerical problem is, we know very well about the Thomson method, so we are going to first start from the Thomson method. So now we have the real part as u is equal to x square minus y square, and we know the Thomson method, or you can say Thomson formula also, as f of z for finding the analytic function. F of z is equal to integral of phi 1 z comma 0 minus iota phi 2 z comma 0 over all dz. So now to find f1z0, taking partial derivative of u x square minus y square with respect to x. So phi 1 x comma y is equal to del u over del x is equal to 2x. But my need is phi 1 z comma 0. For that we are taking x as z and y as 0. So after taking x is equal to z and y is equal to 0, now phi 1 z is equal to 2z, and again to find phi 2 z comma 0, differentiate u means that the real part with respect to y. So phi 2xy is equal to the partial derivative of u with respect to y is equal to minus of 2y. After the replacing x is equal to z and y is equal to 0, because my need in the Thomson method is phi 1 z comma 0 and phi 2 z comma 0. That's why we are going to find out phi 2 z comma 0 is equal to 0 on putting phi 1 z, means that phi 1 z comma 0 and phi 2 z comma 0 in Thomson formula, that is to find out the analytic function. We get f of z is equal to integral of, on the place of phi 1 z comma 0 we have the value of is 2z minus iota of phi 2, and the value of phi 2 is 0, that's why we are going to put here 0. So f of z is equal to the integral of 2z minus 0 dz is equal to 2z square over 2 plus iota c. So finally we have f of z is equal to z square plus iota c, which is the required analytic function, where z square the real part and iota c are the imaginary part. So this is the way to find out an analytic function by using the Thomson formula.